Okay, we've got another integral here. This one's a really nice one. So this is an improper integral because our function isn't actually defined on the domain of the limits. So the way that we approach this might be a little bit different to the way we approach usual integrals. Nevertheless, the ideas are still the same. So I'm going to make a substitution x is equal to tan theta. And that's for two reasons. One, I know that when I differentiate tan theta, I get sec squared theta. And I also know that 1 plus tan squared theta is equal to sec squared theta. So that denominator is going to cancel out when I differentiate x equals tan theta here. Okay, cool. The other reason is if I substitute tan theta for x into arctan theta, I'm just going to get back theta. But there's a slight caveat to that, which we'll touch on later on. Okay, well, let's differentiate this. So we're going to have dx is equal to sec squared theta d theta, right? And let's think about our bounds. When x is equal to 0, we know theta is going to be equal to 0. And when x tends to infinity, theta is going to equal pi over 2. Or really, I should say, theta tends to pi over 2, right? Okay, that's nice. So now I can transform this integral. So now I'm going to have the integral from 0 still to pi over 2 of arctan of tan theta. And I'm going to divide that by 1 plus tan squared theta. And I'm going to multiply that by sec squared theta d theta. Oh, there should be a c there. Right? My denominator is equal to sec squared theta. So those will cancel. And then I just have arctan of tan theta, which is theta. Now, is it really theta? Let's have a think about this. Arctan of tan theta is only equal to theta if and only if theta is in the interval from minus pi over 2 to pi over 2, the principal values of tan. Now, the principal domain, I should say, of tan. Why is that? Well, it's because tan is a periodic function, right? For example, if I have arctan of tan of, let's say, pi over 4, sure, that's equal to pi over 4. But if I also had arctan tan of pi over 4 plus any integer multiple of pi, that will also give me pi over 4, right? And so I need to make sure that my theta is in this range. And I know that this function here, arctan of tan theta, is in that range. And so when I evaluate arctan of tan theta, I'm going to get back theta. Okay, we can integrate this really easily. This is going to be theta squared over 2. I'm going to evaluate that from 0 to pi over 2. Okay, substituting in pi over 2 here, we're going to get pi squared over 8, because I'm going to get a pi squared over, that's going to be 4, and that's going to be over 2, so this becomes pi squared over 8 minus 0, and so I is going to be equal to pi squared over 8. Okay, a really nice one, a really quick integral as well if you spotted the substitution. Hope you guys enjoyed it. See you in the next one.